Hi guys, and welcome to the second video on iteration. Please do make sure you've watched the first video because it will really help you for a big chunk of this this video if you do know what you're doing and how to answer questions like you saw in video 1. So before we get into iteration, some pretty horrible and pretty high level maths, I just want to have a little bit of a distraction. I just want you to imagine a skyscraper. It doesn't have to be as badly drawn as mine is, but I'm a maths teacher, not an art teacher. Now inside the skyscraper, I want you to imagine a lift. It's a really old lift and it's moving really slowly up or down. So I'm only going to tell you a few little bits of information about the lift. So we've got the main bit of the skyscraper, main bit of your tower and your basement, and the lift goes between the top and the bottom. So this lift is moving down slowly and it moves continuously. It doesn't start going up or down, it just goes continuously down. At 11:30 the lift was at floor 2 and at 11:33 the lift was at floor -4. So in 3 minutes there's been a 3-minute difference between these two things happening, and the only thing we know is that it was at floor +2 at 11:30 and floor -4 at 11:33. Now there's all sorts of things we could work out about that if we wanted to, or try to work out, but the only thing I can say for certain about something in particular is it was at floor 0 at some point. I don't know how briefly it was at floor 0 at some point between 11:30 and 11:33. Okay, I hope we can all get on board with that. It's not just jumped magically from here down to here. It had to be level with floor 0 at some point before it reached here. And we know that because it went from a positive floor to a negative floor. Now that idea can relate to the first part of an iteration question. So every single iteration question, if it's in a 3-part format, which has got 5 or 6 marks up for grabs, will start off with that idea. So just think about the lift. So show that the equation 2x cubed plus 5x minus 11 equals 0 has a root between x is 1 and x is 2. Now just remember, root just means a solution. So you need to show that there is some value of x, don't know what it is, between 1 and 2 where this is equal to 0. Now you have to be very careful here. I did actually see someone in the mock exams, when you saw these questions, list out a lot of different possible solutions, and their substitution was really good, their maths was really good, but they missed out 2 really important values. They did a lot of work and a lot of writing, and sadly they got no marks, even though they were actually really confident with the algebra. So what you need to do is, first of all, sub in one of the values you're given. Sub in x is equal to 1. So that's going to be 2 multiplied by 1 cubed plus 5 multiplied by 1, take away 11. Okay, if I evaluate that, tidy up a little bit, 1 cubed is 1, times by 2 is 2, 5 times 1 is 5, and I need to take away 11. 2 plus 5 minus 11, well, if I just work that through, you could on your calculator, I know you'd probably want to do that in a high pressure exam situation, but that would give me -4. Okay, and then what you're going to want to do is sub in your other value. Sub in x equals 2. Be really thorough, make a real point of doing the working out and writing it down to show you've got that answer yourself. So that is going to be 2 multiplied by 2 cubed plus 5 times 2 minus 11. Okay, and that is going to give me, well, 2 cubed is 8, and 2 times 8 is 16, 5 times 2 is 10, and I'm going to take away 11. 16 plus 10 is 26, minus 11 is 15. So I can say when x equals when x equals 1, my function, this equals, so the equation equals -4. When x equals 2, the equation is equal to 15. The change of sign indicates a route between them. Okay, because I'm wanting to find the value of x that makes this equal to 0. When it's 1, that is equal to -4. When it's 2, it's equal to 15. It's not magically jumped from it's not magically jumped from -14 up to 15. There have been there's lots and lots of different values in between the two, so it's going to be a decimal in between them, which would make it equal to 0. Okay, so I've ascertained, and that is the way you're going to hit all of those marks, making sure you have been really thorough showing what you need to show. Okay, secondly, sorry, I just need to plug my laptop in. Okay, second part of the question, every single time, is going to be a rearrangement. Okay, you'll have to forgive the Tipp-Ex. I had to write this out myself. I made up an iteration question and it's quite hard to actually get it right, and I did make a little mistake when I was copying it up. Okay, but this is what I was actually aiming for. So you need to show that 2x cubed plus 5x minus 11 equals 0 can be written as x equals cube root of 11 minus 5x over 2. So this is just a rearrangement. But it's actually a little bit nicer than most rearrangements. I'm not saying it's easy because there's some cube rooting going on. It's a little bit horrible, but you've got something to work towards. You've got a hint about where you should be going. Okay, so the first thing that I notice is that I've got a cubed root here. So the chances are my second to last line will be x cubed equals something. Okay, because I had to cube root it just to get x by itself. So I'm going to want to be keeping this cubed root separate from everything else. I also notice I've got 11 and minus 5x here, quite deeply embedded within that cubed root and that fraction. So I think that's probably going to be the very first thing I need to deal with. So what I'm going to do is be really thorough, take it step by step, and rearrange to try and get this. Don't rearrange to try and get something that you fancy just making up yourself. You need to be aiming for this. So you're going to want to, let's just try adding 11 to both sides to give me 2x cubed plus 5x equals 11. And then there's a minus 5x here. So it would work if I take 5x away. That might help me a lot. I can see that in my final answer. So 2x cubed equals 11 minus 5x. Now I could cube root everything right now, or I could divide everything by 2. Now if I look at what I've got here, think about my rules of algebra, I'm going to want to divide everything by 2. Everything is cube rooted, so that needs to be the very last thing that I do. So I'm going to just divide everything by 2 to give me x cubed equals 11 minus 5x over 2. Then I'm going to want to cube root both sides to give me x equals the cube root of 11 minus 5x over 2. That is what you're wanting to prove. You've just gone through the algebraic steps to get there. So don't be put off, because actually there's not too much algebra in there that you can't do. You just need to be confident and know what you were aiming for. Okay, and then the final bit, the actual iteration itself. So this is why it's important you have watched the very first video on this, because I'll be referencing some ideas that we looked at in there. So, starting with x0, so my initial x value is 1, and x subtext n plus 1 is the cube root of 11 minus 5x over 2. Use the iterative process twice I'm going to underline that word, to find an estimate of the solution to 2x cubed plus 5x minus 11. So if you cast your mind back to that previous video when I was looking at the number of people living in a town, I had to use my answer function on my calculator. Okay, I started off by programming in my initial value and then putting that into the equation. So this is my iterative formula and this is my start value. So I'm going to say x0, my start point is 1. So what I need to do is get my calculator and type in first of all 1 and press the equals button. That's stored that as an answer. I'm just going to press the on button just to go back and have a clear screen. Now I'm going to very carefully type in what I've been given here, my iterative formula. So the cube root of 11 minus 5x. Now we need to be careful here. That x is going to keep changing. Okay, so there should actually have been a little n there. Just realised I've missed that out. So that's a bigger clue. That xn just means your current value of x. Now our current value of x is stored as our answer, and it will always be stored as our answer. So I'm going to press the answer button. And then it's all going to be divided by 2. So I'm going to press equals, and I get 1.44224957. Okay, so that is my first process. Make sure you write it down. And then the second iterative process, the second iteration of it, press equals again, gives me 1.237333909. Okay, so it just takes the last answer and then does all of these mathematical processes to it. Now you could actually keep going, but you only need to go as far as the question tells you to. Okay, you could go on 100 times and write down every single one, but there's no need. You would not get any more credit. You would, however, need to make sure you write down your final answer, and it might tell you to round the answer. It just depends on the question. But you will see I could carry on doing this. So this is just for purposes of demonstrating that iteration does go on forever. If I just keep pressing that equals button, you can see I keep getting different answers, but the jumps between them get smaller and smaller each time. Okay, you can see it gets bigger, then it gets smaller, bigger, then smaller, until the changes are so tiny they are barely noticeable. So if I just go a little bit further, this is going to start barely changing. So if we look at the screen here, I've pressed equals and it's not changed. It's not changed because the changes are so tiny it won't even register on the calculator. Okay, so the actual solution is going to be something like that 1.3069. My iterative process got me to 1.23. So whilst it's not dead on, it's a good enough estimate for what the question wants. Okay, so there are 3 distinct skills going on here, but you can do them all. So there's some substitution, some rearranging, and the newest skill, which is iteration. Make sure you program your calculator according to this iterative formula, which will be given to you. You will never have to find one for yourself, and then you'll get your answer. Just make sure you write down every single step of the process. What I'm going to do then is just show you this question. So it's in a similar format. Just going to make that a little bit clearer. Have a go at these parts of the question. So I've got part 1, maybe just pause it and jot down, part 2, and part 3. So maybe pause video, go back and have a go at those questions, and I'll go through the answers in a moment. Okay, So show that the equation 5x squared plus 9x minus 1 equals 0 has a solution between x is 0 and x is 1. So the first thing you need to do is sub in x is 0, and that's going to give me 5 times 0 squared plus 9 times 0 minus 1. 5 times 0 squared is 0, 9 times 0 is 0, and I'm going to take away 1. That gives me minus 1. So if I sub in x is 0, I get minus 1. Now I'm going to sub in x is 1. That's going to give me 5 times 1 squared plus 9 times 1 minus 1. Or 5 plus 9 minus 1, which is 13. Okay, so the sign changes from x equals 0 to x equals 1, showing the presence of a root between them. Notice I'm not asking you to find out what that root is, I just need you to show me that there is a root between them. Show that 5x squared plus 9x minus 1 equals 0 can be written as x equals 1 over 5x plus 9. Okay, so first thing I notice is I've got 1 over, and I've got a lone 1 here. So I'm just going to see what would happen if I add 1 to both sides. I get 5x squared plus 9. Sorry, little technical issue there, my laptop ran out of space. I'm not sure where that cut off, but I've added 1 to both sides, and I can see I've got 5x squared plus 9x equals 1. Now I can see I've got 5x plus 9 on the bottom, and I've got 5 and 9 here. So how could I use that fact? How could I get 5x plus 9? Well, straight away I spot there is a common factor of x in here. So I could try taking out that common factor. X brackets 5x plus 9 equals 1. I've just done some factorisation. And then I could just divide both sides by that bracket. That gives me x equals 1 over 5x plus 9. So it's not an easy thing to spot, and there is no way you would probably think to make x the subject of that formula without this little bit of a hint. Okay? So that is what you'd have to do. It is challenging, but like I said, it's 3 distinct skills. Therefore, if you don't know how to do this, you've still got access to marks here and here. Or if you couldn't see how to do this last part, you've still got access to marks here and here. So it is worth attacking these questions. Now, some of you may notice that what I've got here is actually a quadratic. I've got x squared, x, and a constant on the end. So you could, if you wanted to, mathematically it'd be absolutely fine to do this, use a quadratic formula, or you could try completing the square. But in this question, that would get you 0 marks. It wants you to use an iterative process. You need to do that. Okay, much like when a question says by factorisation, solve this quadratic, you need to factorise it. Do not use the quadratic formula. You are risking getting no marks. You would certainly get no marks here if you use a quadratic formula. You need to use the iterative formula that they have given you. Okay, so I know that x0 is 0. My starting value is 0. You'll notice that is one of the numbers that was quite close to my root, a little bit below the root. And my iterative formula is 1 over 5, my current x, plus 9. And I keep putting in my current x to find the next one. So that is where my calculator comes in. First of all, I'm going to type in 0 and press equals. And then I'm going to type in this formula, including answer instead of x. So 5 times answer, plus 9. Okay, and if I press equals, it gives me x1 is 1/9, or 0.1111. Press equals again and it will carry out my next iteration. x2 is 0.10465111, etc. Notice it says use the iterative process 3 times. So one more iteration gives me my third value. My estimate is going to be 0.105006 with the recurring notation above the 1 and the 6. Okay, I can leave it there. Okay, if I keep going I'd get an even more accurate value, but I don't want to. It says to do it 3 times, I've done it 3 times. So that is the formula that the format, sorry, that an iteration question is likely to come up in. Okay, it's a case of substituting, rearranging, and the iterative process. Okay, once you get your head around the iterative process, it's actually just knitting together a lot of skills that you're already good at. So whilst iteration is a scary topic, whilst lots of people across the country probably are not going to bother with it because it looks horrible, I'm confident you are able to do this. So hopefully this has been helpful, guys. If you do need anything, please do let me know, and best of luck with your revision.